Just got to disprove humanity real quick. Everything it's ever known. Here we go. Units have never been properly defined, ever. There is not a unit which exists in the physical universe which has been properly and completely defined. If you look up the definition of unit, you'll see it is an increment of measurement. Now, if you read up on whether or not you can replace a term with a definition, you're allowed to. So you can replace measurement with its definition. And the definition of measurement is something attained with quantities and units. We'll just say that. So here we have the definition of unit being an increment of measurement, and the measurement being something attained with quantities and units. So when you replace unit with the definition, you, inside of the definition of measurement, you get an increment of quantities of increment of quantities of increments of quantities of increments of quantities of increments of quantities if you continually replace measurement and unit with their definitions. Now this goes on forever, which makes the definition infinite. If the definition is infinite, it's never complete if it's ever recorded. Not only with that, you have the fact that it is never including anything which is physically relevant, which makes it non-physically applicable. And you can do this, you can think of it another way. You could take a unit which we seek to understand, which we think we understand, and we can disprove it with classically understood laws of physics, even though those are all wrong. So if you take a specific unit that was ever used, you have to recognize that it isn't constant at all, and it has to be constant to be used in measurement. For if you take a measurement with an increment of something that is not constant, then the measurement changes. And measurements aren't supposed to change. They're supposed to be measured, and it's done, and it's there, and it's permanent. It's supposed to be physically valid. Now, if units fall apart because they're subject to the second law of thermodynamics, which states that mass and energy have a general tendency to dissociate and decay in the natural universe, then all your units fall apart and they're never the same. They're not perfectly describable. And if you want to try and define any unit in entirety, such as an atom, you have to define it with its subatomic particles, as well as its position, as well as the gravitational field which is applied over it, as well as its kinetic energy and its thermal energy and the energy of all of the electrons. And you would have to also understand the position of the electrons as well as their rate, which according to Heisenberg's uncertainty principle can't be done. So we can't even fully understand a unit in the first place, or an atom in the first place, which is a unit. So if we can't fully describe an atom, how are we supposed to fully describe a particle which is larger, something which is composed of more of these atoms? Whether or not they're bonded, it is still a collection of atoms which have relationships, which makes everything more intense, doesn't it? Or does it? Or do you have to define an atom with all the physical universe around it? It's a good question, isn't it? Should you define an atom with everything inside of it, or everything around it, or both? For if you gave it only everything inside of it, it would be still not perfectly described, for you'd be able to interchange it with another one. You see that? You see the problem there? You see this physical problem? There's a big problem with this, and I have a theory that we're not ever going to be able to understand the most basic unit, if there is one, if it isn't infinite. So let's say that the universe doesn't get infinitely precise and small and tiny. Let's say that there is a bottom line. Let's say that photons are the smallest thing you can get to, and that all mass is comprised of photons. We can't understand a photon in entirety unless we can. But if we were to measure it, how would we get the information back? Are you going to interact with photons? With photons. How are you going to create a picture of it? How are you going to perfectly describe it? To define it? You can't. There's no definition of units. Whether you attack it lingually or physically or mentally, you cannot define it. All language doesn't make sense. I'm gonna put that in another video.